Welcome to a lesson with Dr. Powell. Let's take a look at some features that can sometimes happen on functions. Suppose that we draw a function that looks something like this, like this, like this, and maybe like that. Okay, kind of a funny looking function. Now, if you imagine going from left to right, just as we read, imagine walking along this, and you're walking in the direction of reading from left to right. Now, what happens here on the graph right now? Notice how we're going downhill. That means that on this portion of the graph, we say that the graph is decreasing. These are just words that, of course, that tell us about a graph. On this part right here, the graph would be increasing. On this part of the graph would be constant, at a constant height. From here to here, again, it's increasing. And from here to here, we see that's decreasing. And we also have a couple other thoughts. Right here, we call this a local maximum. A local maximum of what? Not of x values, but of y values. Nearby, it's the biggest y value nearby. So this maximum refers to y value, maximum y value nearby. Similarly, if I would extend the graph and have something that goes like this would be a local minimum. We call it local because it just says nearby, it's the lowest point. Okay, at least in y values. So those are for y values. Okay, now we need to be able to discuss when a graph or a function is decreasing, increasing, and how do we notate that? How do we talk about it? Well, remember what functions are. They depend on the x value. The y value always depends on the x, which means that if you're talking about where something's happening in a function, just talk about the x values. The x values tell you where you're at on the function. If you know an x value, you know the y value. And so just by convention, when the question is ever asked where something's happening, always talk about x values. Don't even bring in the y's. If you bring in the y's, it's just not what is usually done or standard or expected. And what's usually asked in textbooks and so forth, they only want x values. So we want where, only give x values. In fact, don't just give x values, give a whole interval of x values. So and don't give anything else, all right? So let's suppose, for instance, that we have the following graph. And let's suppose we have something that looks like this. Okay, and let's see, that looks good. Let's just do that. All right. Suppose this point is 5, this point is 2. Let's just say that point's a half. Suppose that this point is -2, and let's just close that off and suppose that this is -4. Okay, then the question is, so if we want to know where is this function constant? Now, to answer this, if we're talking about being constant or increasing or decreasing, let's always use open intervals with parentheses. So if we're going from 2 to, so here constant, notice it's from 2 to 5. Now, it's kind of, you might look at 2, 5 and think, hey, that's an ordered pair of x, y. Well, it's not, because when we're answering the question where, we're going to just give x values, okay? X values. So if this is just x values, this is corresponding to an interval right here. And it also might look funny, especially since we're using these open parentheses here, these soft parentheses. And so it looks like an ordered pair, but it's not. It really refers to an interval. So from 2 to 5 is the interval where this function is constant. Now, where is this function decreasing? We're also going to give that an interval notation, and it's going to be x values. Now, there's two locations right here from -4 to -2. Don't include the y because remember, the y's depend on the x. So we go from -4 all the way to -2. And we also have another place. We can union this with 1/2 to 2. So that's where this function is decreasing. Where is this function increasing? Okay, well, if we go from -2 to 1/2, that is perfect. Okay, so that's where this function is increasing. Where does this function have a local maximum? Notice it's at 1x value. So in this particular case, local maximum and minimum, really we just give specific x values, not an interval, but it's an x value. So where does it have a local? Where does it have a local maximum? X equals 1/2. Where does it have a local minimum? At x equals -2. Now it's interesting because if you were to actually say what the maximum is, notice there's a difference between what and where. What always refers to y value. That's kind of funny. Just be so careful on the subtlety there. What is y value and where is x value? Because so the what about the function are y values. So if I say, so this would represent the local maximum. This represents the local minimum, but it's not the local minimum. This is where the maximum is, and this is where the minimum is. This isn't the minimum, this is where it is. That's where it is. So if you want to know what it is, you need to know what the y values are. So let's suppose, for instance, that this y value right here were 4.5, and this y value right here is maybe like -2. Well, I'll make it a little different. What if I say it's -2.5? All right, then that tells us the what. So if I say what the maximum is, you would say it's 4.5 at x equals 1/2. What's the maximum? 4.5 at 1/2. 4.5 at 1/2. There's the at, and the what is right there. What is the minimum? -2.5. Where? -2. So what is just code word for y, and where is code word for x. Thanks for watching.